And we're going to begin to approach the idea of solving simultaneous linear equations and matrices. Okay, so simultaneous linear equations and matrices. Start with the problem of finding the equation of a straight line. Okay, equation of the line in general is y equals mx plus b. Any straight line can be represented by an equation of this form where m is the slope and b is the y-intercept. Now here we have straight line through the point, what, x is -6, y is -7. So x equals -6, y equals -7. Here, well, let's just say we have the point -6, -7. Then over here, x is 3, y is 10, so this point is 3, 10. What's the equation of the line? We don't know, but we know it has a form y equals mx plus b, and we have 2 points, each with an x and a y. So we plug the x and the y from one point into the equation, plug the x and the y from the other point into the equation. They'll give us 2 points, or two equations, which we can hopefully solve to find the equation. Let's just plug the points in first. Okay, if x is -6 and y is -7, the equation becomes -7 equals m times -6 plus b. If we plug 3, 10 in, we get y equals 10, so that's 10 equals m times 3 plus b. Now this is 2 simultaneous equations. I'm going to rewrite them slightly, and I'm going to rewrite the first equation as -6m plus b equals -7. And the second equation as 3m plus b equals 10. All I've done is switch the sides. And instead of m times -6, I write it as -6m. Okay, now this gives me 2 equations. I'm going to designate the first equation with a circled 1. 1 with a circle on it over next to the equation means the equation -6m plus b equals -7 is equation 1. Equation 2 will be 3m plus b equals 10. And to keep track of what I'm doing, what I'm going to do is I'm going to multiply the second equation by 2 and then add it to the first. In order to do that, well, I want to write the first equation down again. And then I want to write 2 times the second equation. So first equation, I'm just going to copy the first equation down. -6m plus b equals -7. The second equation, I'm going to multiply through the equation by 2. So 2 times 3m gives me 6m. 2 times b gives me 2b. And 2 times 10 gives me 20. So now my system is -6m plus b equals -7. 6m plus 2b equals 20. I'll note that I'm writing these things in column. Okay. I wrote my first 2 equations, -6m plus b equals -7, 3m plus b equals 10. Then I put a line underneath. Then I write a circled 1 to indicate, under that line, I write a circled 1 to indicate that I'm again writing equation 1, which is -6m plus b equals -7. And then 2 times circle 2 under that, and the equation 6m plus 2b equals 20. The 6m and the -6m are aligned. The b and the 2b are aligned. The -7 and the 20 are aligned. Now I'm going to rewrite those equations a little higher on the board where I have more room. So that was equation 1, which was negative 6m plus b equals negative 7. And 2 times equation 1. Now, when I write 2 times equation 1, I've just written down equation 1, negative 6m plus b equals negative 7. But every time I rewrite the equations, equation 1 is always going to be the equation 1 in the previous set of equations. So I'm doing 2 times equation 1 from the previous set, which is our original equation 1. Now, that's really doesn't make any difference because this equation 1 is the same as the original equation 1. But just want to clarify that. Okay. Now, I add the 2 equations, which means I take equation 1 from the previous set and add it to equation 2. Write a circle 1 plus circle 2, which means I take the equation 1 and the equation 2 that I just got. Okay, so the 2 equations I see here, well, I'm going to add them. Means that the negative 6m will add the 6m and give me 0. The b will add the 2b and give me 3b. And the negative 7 will add to the 20 and give me 13. So that is simply the equation 3b equals 13. B then equals 13 divided by 3. So I find my value of b. Now I'm going to plug this value of b into one of the first 2 equations, either one. And when I do that, I'll no longer have a b, I'll have a number where the b was. And the only variable I have, or the only unknown, will be m. So I'm going to substitute this into equation 1. So I'm going to say b equals 13/3 into equation 1. Okay. And if I do that, my equation 1 is going to be the equation I just got, which is no good, into the original equation 1. Okay. I do that, I get negative 6m plus 13/3 equals negative 7. Okay. And I'll make a little arrow from the original equation 1 over to this equation, so we're really clear on what equation we're using. Okay, now this equation has denominator 3, so I'm going to multiply everything by the common denominator 3. And I'm going to do that kind of carefully. I'm going to write 3 times negative 6m plus 13/3 equals 3 times negative 7. Then 3 times negative 6m is negative 18m. 3 times 13/3 is 13. 3 times negative 7 is negative 21. Multiplying through by the 3, I no longer have a fraction 13/3. I have just whole numbers, which makes it easier to solve the equation. Well, then I'm going to add 13 to both sides. I'm going to get negative 18m equals negative 34. I think I said I'm going to add negative 13. I'm not sure I said that negative the first time, just to be sure. In any case, we get negative 18m equals negative 13/4, negative 34, and m equals negative 34 over 18, which is negative 17 over 9. And it's not negative because I've divided negative by negative. It's negative 34 over negative 18, which is 17 over 9. Okay. So does that make sense? Well, if we go back and look at the original triangle, from x equals 6, from y equals 3, from y equals, I'll get it right, from y equals negative 7 up to y equals 10, my rise from negative 7 to 10 is a rise of 17. And from that point over to the point 310. I'm going from x equals -6 to x equals 3. This is a run of 9. So again, if I start at my first point, -6, -7, and go up until I'm level with the second point, that's my rise. That's 17. And if I then go from that point straight over to my second point, I see the run is 9. So the slope equals rise over run, which equals 17 over 9. That agrees with what I got here. I could also let I could also take either of my points and plug it into the equation that results. Conclusion, the equation is y equals 17 ninths x plus, now this is y equals mx, m is 17 ninths, and then it's plus b, and we found earlier that b was 13 thirds. Okay, now let's take the two equations that I wrote and rewrite them. Well, let's write them again. My original two equations were -6m plus b equals -7, 3m plus b equals 10. I'm going to write these equations in a shorthand. I'm going to put a square bracket on the left, square bracket on the right, and leave myself enough room to write the coefficient of m, the coefficient of b, and the number to the right of the equal sign. The first equation is -6m plus b equals -7. So I have a -6 in front of m, so I'm going to put a -6 within that bracket. The coefficient of b in the first equation is 1, so I'm going to write a 1. And then I have -7 on the other side. And I put a little dotted line between the 1 and the -7 to indicate that we have an equal sign there. Just to remind myself, it's not absolutely necessary, but it's pretty much always done, and for good reason. Okay, so what I've got now is a row of numbers, -6, 1, -7, inside a set of brackets. Now, the brackets are big enough that I can then write the coefficients of the second equation. I have 3m plus b equals 10. Coefficient of m is 3. Coefficient of b is 1. And the 10 is to the right of the equal sign. So now I have a set of brackets with two rows. First row is -6, 1, -7, representing the numbers in the first equation. The second row is 3, 1, 10, representing the numbers in the second equation. So none of my rows, row 1, row 2. And I'm putting a circle around the 1. So I have row, circle 1, row, circle 2. If I mimic what I did with the equations, well, the first thing I did was I doubled row 2. Well, I'm on the first step on the original solution. I did 2 times the second equation. Here, I'm going to write a set of brackets. First equation I'm going to write be the same. Sorry, the first row I'm going to write will be the same as the first row of my previous matrix. The second row will be 2 times the second row of the first matrix, which is 6, 1, 10. Okay. Now, what I'm going to do, I'm going to write row 1 again, same as in the previous matrix. I've written a new set of brackets, and I'm going to write my row 1 from the previous set, which is 6, 1, negative 7. But in the second row, I'm going to do row 1 plus row 2. Now, if I add row 1 to row 2, it means in row 1, in the previous set, I have negative 6, 1, negative 7. In row 2, I have 6, 1, 10. So I'm going to do the negative 6, which is right above the 6, negative 6 and the 6. In other words, the first column of my previous matrix adds up to 0. The second column, I made a mistake when I wrote the second row of my previous matrix. I multiplied 3 from the previous matrix to get 6. But when I was doing 2 times row 2 before, I should have done 2 times the row 3, 1, 10. And I multiplied the 3 by 2, but then I just wrote down the 1 and the 10, which is wrong because I got to multiply everything by 2. So multiplying, okay, my original row 2 was 3, 1, 10. Multiplying every number by 2, 3 times 2 is 6, 3 times 1 is 2, 3 times 10 is 20. So I previously had 2 times the second row in the second matrix that I wrote as 6, 1, 10. It should be 6, 2, 20. Okay, now, again, back to adding row 1 plus row 2. The negative 6 is above the 6. I add those to get 0. In the second column of the second matrix, I have 1, 2, which adds up to 3. And in the third column, I have negative 7, 20, which is 13. Now I'm going to do another operation, which doesn't strictly correspond to anything that I did before, but it's pretty close. I'm going to multiply the second row by 1/3. The reason I do that is I want a 1 in the second column, second row. That is, the second number in the second row should be a 1. Now, I'm not messing with the first row. That's still negative 6, 1, negative 7. Okay, I get 0 in the second row, 1/3. I'm taking 1/3 of each of the numbers, 0, 3, 13. 1/3 of 3 is 0. I write that down. 1/3 of 3 is 1. I write that down in my new matrix. 1/3 of 13 is 13/3. I write that down in my new matrix. Okay. Now, another thing I do that I would ordinarily have done much earlier is I take my row 1 and I divide it by 6. So I've got a new matrix. I'm going to do the negative 6 divided by 6, which is, but let's divide by negative 6. I've got my negative 6, which I can divide by negative 6 to get 1. I've got the 1 divided by negative 6 gives me negative 1/6. I've got -7, which divided by -6 gives me 7/6. My second row is going to be the same as it was before, 0, 1, 13/3. Now, what do I have? I have a matrix that still represents a set of equations equivalent to the one I started with. Let's be clear about what that means. First of all, the matrix -6, 1, -7 in row 1 represents the equation -6m plus b equals -7. The 3, 1, 10 in the second row represents 3m plus b equals 10. Okay? So the equation that I just got, which is 1, -1/6, 7/6, 0, 1, 13/3 represents the equations x minus, not x, m okay, the 1 in the first row of 1, -6, 7, 6. The 1 represents the coefficient of m, just like the -6 in my original matrix represented the coefficient of m in -6m plus b equals -7. So the number in my first column always represents the coefficient of m. Number in my second column always represents the coefficient of b, and the number in the third column always represents what's to the right of the equal sign. So 1, -6, 7, 6 means 1 is the coefficient of m, means I have 1m. And then -6 is the coefficient of b. That's going to give me -1/6 b equals 7/6. Second row, numbers are 0, 1, 13/3. The 0 means I have 0m plus 1b equals 13/3. So again, the row 0, -6, 7, 6 represents 1m minus 1/6 b equals 7/6. 0, 1, 13/3 represents 0m plus 1b equals 13/3. Now I can rewrite that more coherently. 1m is just m. -1/6b equals 7/6. And 0m doesn't even have to be written. 1b is just b, writing the second equation, equals 13/3. I can take the b equals 13/3 and replace b in the first equation. And that gives me an equation I can solve for m. Now, a lot of times, when I get to the matrix -6, 1, -7, 0, 1, 13/3, that would have been my fourth matrix in the reduction process, I can stop there. The second equation, or the second row, 0, 1, 13/3, represents my b equals 13/3. I can substitute 13/3 for the 1 in the first equation and get it in the first row. You can substitute the 13/3 for the 1 in the first row, gets me an equation that I can immediately solve for b. So if I wrote my equations out, at this point of this fourth matrix in the process, I would have a set of equations that I can easily solve for M and B. Now, there's another thing I can do. Once I get the matrix into the final form that we had here, the 1, -6, 7/6, 0, 1, 13/3, I could add 1/6 times the second row to the first, which would give me a 0 in the second column of the first row. And if I did the arithmetic correctly, I would have my solution. We'll do that a little bit later. My point is, we've just let's finish it and then I'll make my point. Okay, by reducing the matrix, I've obtained a matrix which represents the equations M minus 1/6B equals 7/6, B equals 13/3. I can substitute the B equals 13/3 for the B in the first equation, and that gives me the equation M minus 1/6 times 13/3 equals 7/6. Now, this is a little messy. I get M minus 13 over 18 equals 7/6. I have to multiply both sides then by 18, which gives me 18M minus 13 equals 21. 18 times M is 18M. 18 times -13 over 18 is -13. And 18 times 7/6 is 21. I'm not going to go through the details of that fraction, but be sure you understand those details. Which gives me 18M equals 34, so that M is 34 over 18, which equals 17 over 9. And it shouldn't be surprising that I get exactly the same values for M and B from this process, from the matrix reduction process. I get B equals 13/3. I get M equals 17 over 9. Exactly the same numbers that I got when I solved the equations. Okay. So there's no difference in the result of the two methods. Now you might wonder, why do we bother with this matrix reduction stuff? Well, when you get into more equations and more unknowns, it becomes much more efficient. And also, you'll see later how this system of equations can be represented as a matrix equation. And matrix equations, if you got a big matrix, you don't want to do this all by hand. There are too many steps, too much chance of error. You have to be able to do the process to understand what's going on. But once you get good at doing the process by hand for small matrices, you could write big matrices and put them into computer algebra systems, which were a dime a dozen, and get your solutions in just a couple of keystrokes. Well, a little more than a couple of keystrokes, but it's very powerful to use matrix methods. And matrix methods are very easy to program into a computer. One of the first things people did when computers were invented was they started doing linear algebra with things. They started using matrices and stuff. So that's something that you see in your pre-calculus course. It's in your pre-calculus course because it's important later. And whether AI is doing it for you or not, it's something that you want to understand so you have a picture of the structure of a solution of a problem instead of just a blind acceptance of whatever AI tells you.